Okay, hello. Today we're back with another video. Um, Subsets 2, we did subsets 1 yesterday. Um, it's the subset, what do you call it? The subset coding pattern. There we go. That's the word I was looking for, subset coding pattern. Um, yeah, basically, we'll continue with this until either I think it's too hard, only because even after reading the solution, I completely don't get the solution or like understand how it was implemented at all. So yeah, we'll keep doing these until we get there. So without further ado, let's get into the question. Subsets 2, given an integer array nums that may contain duplicates, return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order. Um, so basically, there's a very simple solution that you can think about for this, or um, so the very simple solution is where you just have a set. You create literally every subset possible. You throw it into the set, and then you iterate through the set, and you can pick up the whatever's left in the set, right? Because the set will not store any duplicate items, and so you could just throw that there. But then you'd use O of n space, or actually I don't even know if it's O of n. It's technically, what is it? Um, Actually, what would the solution be? So it'd be the empty set, the one with two, the one with one, two, and then you'll have the another one with one, two, and you'll have one with the one, two, two. And you also have the 2 2, right? Oh, you also have the 2 here. So it ends up being 7, but instead we have 6 because there's just one duplicate. Um, Actually, 2 duplicates, right? Because you would have two 1 2s. Okay, so if we go through it, 0 and the 1, and then you add the 2 here, and then you add the 2 there too. Also, you have 2 of these as well. Yeah. So, that ends up being what, 8 items. We only have 6. 8 items. Oh, it would be 2 to the n power for like the amount of space, right? Um, but yeah, we obviously don't want that many, especially if you have a lot of duplicates. Uh, yeah, we kind of don't want that. So, using, I guess, not necessarily a subset coding pattern. I mean, just for this problem, it's you just approach it a little bit differently, um, other than just using a set, right? And so, yeah, that's what we'll be doing here in this video. So first of all, we're going to start off with doing nums.sort because we want to sort the numbers just so we know, whenever we hit consecutive numbers, like if we hit a duplicate number, they'll be right after one another. And so we can handle that accordingly. So that's why we want to start off with a sort. We're going to create a result um, array where we store the empty set to. What I did yesterday was res and then res dot append the empty set, but figured it's probably just easier to just um, just initialize it that way. Um, and then we're going to initialize a variable called end. End is going to tell us essentially the bounds of how far we need to iterate through and then add our current number to. Um, yeah, I think it might make a little bit more sense once we go further on, but I'll also explain it as well. So we're going to do a for loop for I in range of length of nums. We want to initialize a start variable. The start needs to reset every iteration of this loop. That's why the start is initialized here. Otherwise, and the end, it doesn't actually get reset. Uh, and then like the value could potentially be used in this if statement that I'm about to write right here. So that's why we need to initialize it outside so it doesn't die within the scope of this for loop. Um, so here we want to do a condition. If I is greater than 0 and nums I is equal to nums I minus 1, then we know it's a duplicate, right? Because um we only have this I is greater than 0 bound because we can't check I minus 1 on 0 because then it would go technically backward in the array because the nums of -1 would actually take you to the last item in the array, and we actually don't want that. Um, so we will just look at if I is greater than 0, then we can do this check. And if it is, that means we've seen a duplicate, right? And if we've seen a duplicate, then we only want to iterate through the newest items that were created this past iteration. So like in the last iteration of this for loop, because we know that it's a duplicate number. And if we were to iterate through everything again, so let's just say, for example, this question, right? We're going to start off with the empty one, and then we're going to have the 1, and then and so now we get to this 2, right? So this is what we have so far, and once we get to the 2, we look at the first item, we put the 2 in there, look at the second item, put the 2 in there, and then we've handled all of our this first 2, right? But now since we want to avoid duplicates, if we were to just iterate through everything again and append 2 to everything, then we'll have this 2 again, which we don't want. We would end up having this 1 2 list again because looking at this one, and we don't want that. But then we'll have a 2 2, and then we'll have our 1 2 2 because we'll look at this and we'll create the 2 2, we'll look at this and create the 1 2 2. But these are duplicates, right? The 2 and the 1 2 and the 2 and the 1 2, right? Those are the duplicates. We actually don't want those. So that's why this start is equal to end will make a lot like applies, right? So we set end is equal to the length of result. So okay, actually let me explain that part again. So basically we're going into the iteration where we have the duplicate number, right? Because we start off with the empty one, and then we do the 1 where we just add the 1 to the empty, and then we get this. And then we hit the first 2, and since this is the first time we've seen the 2, we iterate through the empty one again, we append the 2, we go through the 1 with just the 1 in it, and we append the 2, and we get 1 2. And now our end is the length of this, which is 4, right? And so we see that this, oh sorry, the end is before we append, right? So the end is actually 2. And because we do a for j in range of start to end, so appending these items actually come later, right? So our length is currently 2, so end is at 2. And then so now after we add these, our end is at 2. And so when we iterate through the loop again and we hit this first 2 right here, our start initializes at 0, but then we realize we're looking at a duplicate, so we make it equal to end so that we actually start here, or sorry, 2, the length of 2, so we start here, which is at this index, which is the place where we started appending our last answer, right? So now we know we only want to iterate through these and copy them and then create our solution based off those. And then if you look at that, we actually have skipped through these first two, which would have caused us to create the only duplicates that we would have. Because remember how earlier when we ran through the solution, we had two of the 2 and the 1 2s. Um, that actually saves us from the duplication, right? And so just to finish off the solution, for j in range of start to end, regardless of like either we start from the very beginning and then we iterate all the way through, or we just start from where we last started appending our last iterations solutions, and then we'll only go to the end of that, which is like in this case it was only 2 items. It was the 2 and the 1 2. Like this isn't ordered in this array in the order that like we would return our solution, but um yeah. So we get here, we're going to make a copy, which is just a list of nums j. We're going to do, sorry, not nums j, res j, because we want the from our solution array, not from the nums. We're going to copy dot append nums I here, and then we do result dot append copy, and then here we just return our result array, and that should be the solution. So if we just run through it all again, we initialize with the empty set, we go through the first time. If it's the first time, there's no way we have a duplicate, so we set the end, which is just still 0 because we have 1 because there's nothing in just because of the empty set. But if somehow we make a copy, then we don't want to iterate through the empty set and then make another copy of our empty, like the empty set plus whatever number, because guaranteed we're going to have that already. We set the end just so for our next iteration through we know where we stopped, or like where we need to start from. And then we just do the simple thing, what we did yesterday, which is just copy whatever we're looking at currently, we add our number, and then we append that to the answer, and then that will help us build out our subset. And then at the very end, we obviously need to return our result because we want to make sure that uh you know whatever's calling us actually gets what they're expecting, which is a result, which is a list of ints, which is something like this. That being said, let's run the solution. And yeah, it passes the test. Yeah, thank you for watching.